Way number 9 to pass the chemistry reagents deals with ideal gases. When you think of the word ideal, you want to think of perfect. Under what conditions do gases behave most like gases? And this only happens when gases are at high temperatures and low pressures. Think about this. If the temperature is high, the kinetic energy is also high, which means molecules of gases are moving much more randomly and faster. Under low pressures, the gas particles are not close together and as a result behave more like a gas. So whenever you think behavior of an ideal gas, think low pressure, high temperature. So let's look at problems that deal with this idea. A real gas behaves most like an ideal gas at remember, ideal gases are best at low pressures and high temperatures. So the answer has to be answer choice 1. Remember, if the pressure is high, that means the gas particles are compacted closer together, and you get behavior more like a liquid or a solid. If the temperature is low, it means that the gas particles aren't moving very quickly, which means you're not behaving much like a gas at that point. So the answer has to be 1. Compared to a sample of helium at standard temperature and pressure, STP, the same sample of helium at a higher temperature and a lower pressure, if you see high temperatures, low pressure, you should be thinking ideal gas behavior. So the answer choice has to be 4. Base your answer to the question on the information below and on your knowledge of chemistry. The diagram and data below represent a gas and conditions of pressure, volume, and temperature of the gas in a rigid cylinder with a movable piston. So here's this nitrogen gas, N2, inside this piston, and we can adjust the pressure by changing this piston, and it gives you initial values for pressure, P, volume, V, and temperature, T. Currently, this is at 1 atmosphere of pressure, 2.5 liters of volume, 298 Kelvin. It says, state one change in temperature and one change in pressure that will cause the gas in the cylinder to behave more like an ideal gas. So look at this idea and think about what the answer is. So what can we do to the conditions in order to get this to behave more like an ideal gas? Well, we have to increase the temperature so the gas particles move faster, and we have to lower the pressure so that the distance between the particles is also high. Therefore, the answer has to be increase the temperature and lower the pressure. A sample of hydrogen gas will behave most like an ideal gas under the conditions of Again, when you see ideal gas, think low pressures, high temperatures. Only under these conditions is a gas most ideal. Let's try this last problem. Under which conditions of temperature and pressure does a real gas behave most like an ideal gas? For this problem, it gives you actual values for temperature and pressure. So when we think ideal gas, we should think high temperatures and low pressures. The only one that shows the highest temperature and the lowest pressure is answer choice 3, 347 Kelvin and 1 atmosphere. The only other way that this problem might appear on the reagents that might like to trip you up is they'll switch things and ask under what conditions will an ideal gas behave most like a real gas, in which case everything is inverted. If something is behaving like a real gas, we're inverting the conditions, which means that the pressure is being increased and the temperature is being decreased. Hopefully this helps. Thank you.